Hello, welcome to Azure Kubernetes deployment series part 6. In this series, we are going to learn how to deploy microservices into AKS cluster using Helm chart and Azure DevOps pipeline. In this series, mainly we focus how we will update the image tag automatically in the Helm chart values.yaml file through the Azure pipeline. In the last lab, we have already discussed how we have deployed the microservices using Helm chart and automated through pipeline. But one thing we have done is the image tag we have manually updated in the values.yaml file of the Helm chart. So in this session, mainly we'll discuss how we can implicitly update the values.yaml file of the image tag of in the Helm chart. So in order to do that, here if we know in the last lab we have created a Helm chart, and in that under that Helm chart, if you go to the templates folder, so here it contains all the manifest files of all the applications and the configuration. You can see here we have order, product, RabbitMQ, store, as well as the config. So everything is included as a single Helm chart. Okay, so in this case, the problem is, suppose we want to only deploy the order application or order service or product service or RabbitMQ. That we cannot do using a single Helm chart. And also we cannot use the same build ID and update it into the values.yaml file automatically using the pipeline. So in order to update that image tag individually for each of the services, what we can do here, we need to create another Helm chart. So you can see I have created a store Helm chart, and under that I have created individual Helm chart packages. You can see for order I have created one Helm chart, and under template we can see this is our order deployment and service deployment. Similarly for product also I have created a Helm chart, RabbitMQ and storefront as well. Also for config um, the config chart also I have created a Helm chart as well. So here you see we don't have deployment or service YAML file, but I have the config map YAML file. Okay, so here under the storefront Helm chart folder, we have created 5 different Helm chart. So that mainly used for the individual applications or services. Okay, so how we can do, how we can create those Helm chart, that I can just show you. If you can see here, using Helmify, because we have already the available manifest file. You can see I have already the manifest file, and what I did is I just segregated or grouped this manifest file depending upon the service. So here if you can see under order I have two YAML files, the deployment and service. For products also similar deployment and service YAML file. And configuration, config, under config I have the config map file. Similarly for Rabbit message queue and storefront, I have the respective YAML files. Okay, so I have this manifest file, and in order to create a package using only the other YAML files, what I can do is I have to use helmify command, and under that, if you see, I'm using the manifest folder, and I'm just using the order folder of this manifest. So under manifest, I'm using this order folder, and under these two files only, and I'm copying, I'll create this package under store Helm chart. So this is my store Helm chart, and under that the order folder, so it will create here. So it is already created because I have already run this helmify command. So similarly for creating the product Helm chart, I have used this command. Okay, so it will read the YAML files, the manifest files from the manifest folder, manifest product folder, and it will create the Helm chart under the store Helm chart folder and under the subfolder product. Okay, so the same way I have done it for all the 5 Kubernetes objects. Okay, so then we need to create our YAML files for setting up the pipelines. Here, if you see under Azure DevOps, I have these YAML files. You can see I have a order YAML file that is called order pipeline YAML. So in this case, in the same YAML file, I mean the same pipeline, we will create the Docker image. You can see I'm building the Docker image and pushing it to the Azure Container Registry, and it will publish that manifest file. So manifest file is nothing. The package what you have created is here is the store Helm chart. So it will publish to the publish directory. Okay. Next, the deployment, it will download that manifest file. It will download the store Helm chart from the uh, artifact folder of the agent machine. Then it will, in the next task is it will log into the AKS cluster. And what we are doing here is, here if you see I'm using the image tag, so it will dynamically create a tag depending upon the pipeline build, and it will append that tag to the Docker image and push it into the Azure Content Registry. And whatever it created and it pushed into the artifact, in this task it will just replace that tag with the image tag. If you see here, the image tag is nothing the build id. So this build id will be replaced in the values.yaml file, uh, that is in the artifact. Okay, so it is already downloaded here, and you can see it is downloaded here. It is already downloaded and into the local directory, and here it will replace that values.yaml with the image tag. Okay, so if you see here, order deployment, okay, here the values under order values, if you see the tag is v1, but we are not going to use v1 because in our ACR content registry it will push with the image with a build id tag. Okay, so that it should use that build id tag to pull that image and deploy into AKS cluster. Okay, so in order to do that, so we have used this set command here to replace the image tag with the build id. Okay, so next, using Helm deploy, we are going to provision deploy the Docker image into the cluster, AKS cluster. It will pull from the ACR content registry and deploy it into the AKS cluster. Okay, so the same pipeline, for 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 the order service, it will build the image, push the image with the build id tag into the HCR container registry. Then it will publish that Helm chart. The deploy stage will download that Helm chart from the artifact, and it will replace the tag with using the set command here, and the Helm deploy will pull the image from the ACR and deploy it into the AKS cluster. Okay, now if you can see here, if you go to my pipelines, Azure pipeline here, I have already created, you can see here, I have already created the images, the pipelines. You can see I have already run this order pipeline. Okay, and this order pipeline already deployed. It already pushed these images. You can see here it is already pushed that image to Docker content registry, and also published the artifact, and the deploy stage. It already deployed the Helm chart into AKS cluster. So if we come here into my Azure Container Registry, so you can see here order, it has the latest 394 as the tag, Similarly, for product image, it is 389, and for storefront is 390. Okay. Now, if we can see, for example, if you want to see the pod image that is already deployed, we can do that using kubectl describe the pod, the order pod. The name of the pod is this is the order pod name. So here you can see under image, you can see the image ID and image. So you can see 394. The tag is 394. So it pulled this latest 394 and it is deployed. Okay. So and the application is already deployed also. You can, if you see get pod, so it will see everything, all the services are deployed and it's running. And if we do okay, this this is the public IP of the storefront service, and we can call to this public IP to access the app. So you can see here Contoso pod store. Okay, whatever the information is there, if you can see under app, storefront, and under index.html, it is Contoso pet store. Okay, now in order to check how this tag is automatically um, updated in the values.yaml file of the Helm chart, in order to this demo this, let again modify this storefront application. So just let me just update it like append with welcome. Okay, so let modify something like this. Now let me save this one. So after pushing to the repo, it should run the pipeline. You can see if we'll go to the pipeline here. Now you see after modifying that and push that code to the repository, it automatically deployed this. So it will first build the image and push it to the ACR with a new build tag. But last time it got failed. Why? Okay, let's see. We'll see how it is going. It will take some time to build the application and push it into the Azure content registry. If you go to the code here, the pipeline, if you storefront pipeline, so this will push to the Azure container registry, and it will download the, sorry, publish it. Then it will download, and in this place it should replace the build ID with the storefront values.yaml. Okay, now it is starting here. Let's see how it is happening. Okay, you can see here, if you come, the image tag got failed. Yeah, so the pipeline, it failed because there was some problem with the service YAML file of storefront pipeline. I have just fixed that one and rerun the pipeline. You can see this just now, it is success. And if you go to the deployment and check the updated values.yaml file here, you can see 396 is the tag. And from the repository, if we come and see, it is 396. Okay, and using that, it is deployed to the cluster. Now if we get the pod, you can see everything is running. And if we get the services, you can see this is the new IP we just got. And if you call it, You can see here the new message, whatever is modified here, welcome, that is now it is displaying. So in this case, in this deployment, what we observed is we have only modified the tag automatically using the pipeline. If we go here, I'll just explain one more time. So this is the code here that appending the new build id tag to the image in the values.yaml file. So there is no uh, user intervention is required for updating this YAML file. So now it is the CI and CD, both the continuous integration and continuous deployment, both execute sequentially and uh, without any manual changes. Okay. Now in this lab, we learned how to automate and deploy the services into cluster without any manual change. But there is another change required into this lab. Here in this lab, we are using our manifest files, or the Helm chart is in our repository, and we are taking that Helm chart to the artifacts. From there, it is getting deployed to the cluster. But this is not a best practice. So this, like how we are putting our Docker images into the ACR, similarly, we can also push the Helm chart into ACR, and from there we can get it and deploy it into, I mean, the Helm chart we can use from the ACR to deploy it into the AKS cluster. So for that, we'll discuss in another lab. So for today, that's all about the Helm chart deployment. So in the next lab, we'll learn how to push the Helm chart to the Azure Content Registry and deploy it from there. So till then, bye bye. Thank you.